The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Just a quick heads up, a reply if you could hear me and also my screen. I would appreciate that. I will give everybody a chance to join us as well. Thank you, guys. Okay, we'll give just a minute or so for everybody else to join, and then we'll begin. And thank you very much for joining me and for our fourth webinar. Right, okay, let's begin. So for this morning, rather than me spending almost most of the presentation on SimSolid, I just wanted to sort of demonstrate how many of our customers are using Inventor and Nastran, just to give you a feel and flavor for how, for example, the session regarding to this morning about welded and fabrications is a pretty important topic. I get asked lots of questions how to model fabrications and contacts, and the honest answer is there's no straightforward method. Hopefully that may not be the case with SimSolid. It should be pretty straightforward, but obviously let me go through, show you what happens and how people do it in Inventor and how they do it in Nastran. Obviously the process is very similar with other technologies. And then, but before we begin, I just wanted to ask a question. I mean, if you want to reply in the chat or something, maybe just to get some feedback. I mean, obviously there are different opinions of whether we should model welds within our FEA. There are different best practices approaches. Some people don't some people don't include them. It's all intuition. But obviously this topic is around weldments. I just want to have a think about what the consequences you think, if that's the right word, of actually putting welds into our FEA model. Just to give you some thoughts. How do you actually model a real life weld, for example? What you see on the right hand screen is a weld, probably not a great job, but it is a weld of some form. And then on the left hand side, we have some form of simplified or idealistic approaches of welds. And to make it more complicated, a weld, in addition to geometry, has other properties: chemistry, carbon, manganese, hydrogen, temperatures when it's welded, things like residual stresses. So it's I think it's a pretty big topic in itself. And the real big question is, can we actually really size welds using FEA? Now, if you have been using FEA for some time, and you have tried to model welds, one of the biggest issues we have is that we get hotspots or stress singularities or localized yielding. An example, if you can see me on the first example, and then even before we do any FEA, we have to estimate the size of a weld. So we can't allow the software to determine whether, if the weld is going to be big enough, we need to come out with some sort of weld size originally before we actually do any FEA. And based on my previous slides, can we actually really model a weld? Now, there is a document which, if you're interested, I can forward to you. This was when I was sitting in a class in AU Vegas by some experts, and the first thing he put on the slide was we should not be, FEA software cannot model or size a weld. And there was a huge silence in the class. I mean, I think prior to that, I used to model welds, but the natural tendency for many of us is to model welds of some form or shape. And what you see on the screen is different ways companies have come across with methodologies and processes to simulate, well, that's the wrong word, not simulate welds, but to transfer loads via the welds, which have already been sized using some hand calculations, design codes, or some other mechanisms. And there is no hard and fast rule. Some companies will use solids, some will use shells with some solid fillets, as you see in the example 2. And then you've got 3 and 4 using shells. Now, from my experience, people who do fabrications, which are primarily shells, they won't even bother with the shells because it's just too much work and effort. I mean, I know that sounds lazy, but it just doesn't. There is no real value. If there is a need for an area where there is high stresses, then you could perhaps do a localized study. But what I'm trying to get to is there's no hard and fast rules. So what I'm going to show you here is basically different workflows in Inventor, Nastran, and SimSolid. And then I want to open up the floor. I should have ample sort of questions. I just don't want to spend too much time on the different technologies. I want to show you what's involved, and then questions, because this is a hot topic in addition to fatigue. So let's go straight into Inventor. Okay. Right, first of all, what you see here on the screen is an assembly with a connection, and I basically use weldments here. Now, I know some customers use weldments. Now, obviously, for the fabrication like this, it's a lot easier to fill the gaps in using welds. Now, you can see here, if this weld is not going all the way around, just on the top portion of the fabrication and the bottom part of the channels, you can see the shape of this weldment. Groove weld is not ideal, and it will give us, if analysis was performed on something like this, you will get high stresses in here. So obviously I don't recommend it, but this is the quickest way to actually model it, fill the gaps in. But obviously if you can ignore them, then obviously that's fine. But let me show you what's involved. I want to just talk on the contacts, because that's where most of the time it gets taken. So let's go into stress analysis inside Inventor. Okay. So within the reason why I'm using an Inventor here is because Nastran doesn't allow us to take welds. So if you want to include welds, then Inventor is probably your best choice based on the OTIS solutions. Now if I just go here and just click on the automatic button, even you get a warning from the solver or the saying that we recommend not to include welds in the analysis. But if we ignore that message, you can see for a simple shape like this with 3 channels, box sections, we have a huge amount of contacts. If I just maximize the window, let's have a look. So the first thing we do here is it creates contacts between the box sections itself, so we can suppress them. So basically, if I take the first 4 items here, right hand click and suppress, and that is a process you would need to do with a fabrication with more than 20, 30, 40. The bigger the assembly, the more tedious it gets. And you can see these here are between the welds. Now you can imagine with a fabrication of 40 parts in there, 40 parts, and if you've got welds everywhere, you can imagine there'll be a huge amount of contacts. Now people do ask me, will you actually go to the contacts and check them? And obviously my sort of consensus would be that I will simply run the analysis and get an idea of what is happening. If the stress there is too high, I may go back and check the contacts. But this, I just want to give you the sort of workflow. Now, the other option here is if I now obviously you can use solids here. Solid is one way of doing it. Now the other option here is if I now finish the stress analysis part, and what I'm going to do here is, well, I'll tell you what, we'll use Inventor because it's the same thing as a Nastran. So what I'm going to do here is I'm just going to create a new study. And this process is identical in Nastran. And now what I'm going to do here is another best practice approach is I have seen clients using solid elements, but for something like this, you should be using surfaces as best practice dictates. Now, if I go in here, we can use these principles of extracting mid surfaces of thin objects. So if I do find thin bodies, and just press OK. Now, obviously, Inventor did not pick that one, but obviously it's thin, so I'm going to use the mid-surface option. Okay, so based on that PowerPoint I showed you here, now we have a couple of choices here. We can basically treat the box sections as I have using shells, and then I can have my welds as solids as one of the approaches in the previous PowerPoint presentation. Then if I go in here and now create contacts, we get the warning again, and I have a significant more amount of contacts created. So the ones I have to go here, I'll have to go and suppress all these because there's a contact between that box section, the vertical one, and its edges with the top face of the horizontal box section. So it's pretty easy. So I'm looking for anything with not the welds. So if I just pick the top and suppress them, so now all the contacts will be between the welds and the box sections. And you can see here, and if I was to spin it around, now the weld is not perfect. Now the question is, would I recreate a weld again? Because you can see straight away here, if I just look at one side here, the mid-surface approach is very quick in how it works, but you see you get gaps between your box sections. There's the box section, there's a gap, and there's a gap between the weld and the box sections. And then this begs the question is, do we really need to include the welds, or will the welds have a significant impact on your results or not? So these are the questions you need to be aware of, but based on my sort of intuition and talking to lots and lots of customers, is they rarely use welds because, I mean, I don't know whether it's too much effort or is it going to make any difference to your global analysis. Now, just one more thing I want to show you here. Now what I've got here in a Nastran, because you can't do this inside an Inventor, in Nastran I have idealized the simple frame and remodeled it as a surface model. The reason being is this is another alternative approach. Now, I know some of you CAD gurus can spend hours, maybe days, creating a fabrication, and then if I was to suggest to you, well, remodel it as a surface model, because it will give you a much simpler and cleaner model, then you might not be so keen on the idea because you need to remodel it. But what I want to show you here is something which, I mean, you can have a think about if based down the Autodesk solutions. Now what you see here in the mesh settings button here is, if I cancel that for a moment, you can see the box sections are all touching and you have white lines appearing when I create the mesh. Now what the white lines sort of suggest that is basically we need to create a contact between them. Now the trouble then is I'll have two edges here. Which edge do I pick? That one. There's like multiple edges. Now the quickest way to create contacts between fabrications or shells or surfaces which are touching, you're probably better going into mesh settings. This is the Nastran approach, and click on this continuous meshing. And this is continuous meshing is designed for Nastran. So if I now click on generate mesh here, what you'll notice is that it will merge the nodes of the surfaces. And obviously the mesh could be a little bit more finer, and the only white lines now appearing are on the open edges. Now the only downside with this method here, because I created that box section, the vertical one, which is touching the bottom face or the top face of the bottom box frame, it's touching. So if I want to use this weld, I would have to create a gap between this box section and that one, so there is no contact between it. and then I can go and create a contact using this fillet here. So how do you do, I mean, if I don't want to use a solid fillet, I want to use a surface one, for example, which is another alternative method. I have done this already, so if I just go up to here and drag that and generate mesh again. So what I'm doing here, I'm idealizing the fillet as a surface. If I just hide that CAD body, you'll see it. And if I just click on the shell, just to tell you, so I can specify an average thickness to represent the weld, and you can control the thickness either from the surface of the weld or from the middle of the surface, or whichever direction you want, using these advanced connections here. Now, that's fine, but you have to be aware that that box section is in contact here as well. So you actually extra stiffness, so you have to be aware of that. So you can see straight away, adding fillets or adding welds can actually create more work, and the real question becomes, is it actually worth the effort to get accurate results? So these are the workflows you have to consider within the Autodesk portfolio. But let me show you what happens in SimSolid. Okay, so what I've got here is, just before I do that, I just want to show you one more thing, which I think you might appreciate. If I go to this, I forgot to show you this now. This is also inside Nastran. It's a frame. Now, typically, as you can see here, this is the model I'm going to use in SimSolid. There is this is done using frame generator with all the terminations, and there's no weld preps, nothing like that. Now you have three choices here. You can analyze this using beams. Obviously in beams there is, let me just show you the, hang on. This one is quickly show you this bit here before I go back. Now these are, so you have three choices in Nastran. You can use solid elements. Obviously, you can have the option to model the welds, and probably the quickest way would be to use it using the weldment approach. Or if you're using shells like the mid-surface extractions, because you're going to have gaps there, then it's not so easy to actually include the weld geometry. But if you include surface modeling or remodel the whole thing as surface, then you can you can simulate the welds as surfaces or solids, or alternatively you can do beam elements, which doesn't account for anything to do with welds. So you have these different approaches. If I just quickly show you inside in Nastran, which is very similar to Nastran as well. So if I just go into here, the same thing, I'm going to show you here right there to go find thin bodies. Okay, and then what happens is it will go and pick whatever it considers thin, and now obviously if all the box frames were, and what Nastran does here, it will create a separate idealization for every single beam, even though they are the same cross section. The other alternative approach is that you pick you're taking a 3D wireframe and do it like that. So just give it a moment to. Okay, now if I zoom in, I just want to show you, see, you'll end up with having lots and lots of gaps. So this question begs, well, how do I include the welds? Typically, I think many customers use this approach because it's a lot quicker and a lot slicker, and then the weld question becomes irrelevant, and then they start doing localized studies. This is probably the most common method used within Inventor and Nastran for fabrications, which doesn't without any welded connections whatsoever. Now, when I say welded connections, what Nastran does, it basically will connect the edge with the face. That's how it, and we call it welded connections, because it's not face connections, it's edge to face, and this is something very similar to SimSolid, but in a slightly different way. So let's have a quick look. Right, so let's take this example here. So I've got the simplistic frame. You can see I've not included the welds, for example. So I've suppressed the welds. So if I go to connections, you can see here we can have welded connections, we can have spot welding, we can have seam welds. If I take the fillet weld here, and you have different ways to create the welds. So I'm just going to quickly go through different options. Let's assume this is the master, and then we'll just pick all the parts connecting to the master. And then what happens here is we'll simply say, now find the welds between, as it picked all three, find welds, and there it's found the welds. Now you can see here, it uses that the tolerance section size. Now it's not the size of the weld, it's just basically a tolerance to a region to create the welds. If there's a gap of, let's say, 3 millimeters, then the weld won't be created. If it's a gap between 2, then the weld will be created. Now it's created some welds here. Now it hasn't created any welds all the way around because we need to increase the tolerance. And so let's have a quick look here. What's this done? So if I just go through these options here, now that's a weld between the radius, so I can delete that one if I wanted to, and then the same, keep going to the welds. And next one, and that one there again. So you can basically create welds like that. So if I just press OK. And basically what it's doing here is connecting the edges to the faces, or the edge, depending on what the connection here is. Now what we can also do here, let's pick another example. And let's look at the connections here. Okay. Right, where's the geometry gone? So there's the geometry here. So let's try and give you an overview of the different processes here. Now I can pick the whole geometry. I can use a group weld. So in this case here, we can draw a window around it. So I'm just going to double click all the sort of, and maybe the top ones as well. Okay, and let's just say 2 again. Find the welds, and then it goes and creates all the welds. Now what I'm going to do here is I'm going to see if I can get the weld all the way around. Let's change the tolerance to, let's say, about 9. And now find the welds, and you can see it's got the welds all the way around. And another approach here is you can use weld lines and edges. So let's just go down here. And okay, this might be a little bit tedious, but you can, it's another way of doing it. Okay, spin it around. And then just the last one. And let's pick them all and just get an idea if I missed anything. Okay, the top one here. And let's just start now. I have got an intentional gap between that box section and the hole in it. So I'm just going to try 1 for a moment, see what happens. You get this message, and then we can increase the tolerance to 2. And it's because it's 2 and 2, so maybe need to increase that slightly to 3. And there you go. And then also what you could do here is, and a fourth option, you can, if you have created welds geometries inside Inventor, then you can bring them fillets across, and you can use them fillet as also as physical weld symbols. Okay, so let's have a quick look at the whole frame and see what type of results we get. So let's have a look in here. So I've got the whole frame here. So what I'm going to do here is I'm just going to go through this example. Let's assign the materials. I think it's already been assigned. Let's just check. Okay, let's draw a window around it. Still apply to all parts. So now we've got material defined. And the next thing we're going to do here is, now I'm going to go and create the connection now, because everything here is not going to be bonded or face connections. Everything's going to be welded. So what we're going to do here is I'm going to use the default settings. I think we'll use 9. That's what we did from our, and I'm just going to draw a window around everything. And you can see it creates a bucket load of welds, over 1,000 welds in there. I'm just going to press OK. And I just want to, before I run this, I just wanted to show you a little smart feature which I think is pretty cool. Is that I'm going to, now when we've got to constrain a certain portion of a face inside Inventor or Nastran, we have to split faces. But in here, I'm going to create, let's first of all define structural linear. I'm going to define a fixed constraint using something called spots. So if I click on this face, this side here, create a new spot first of all. Okay. And if I zoom in, let's give a size of, let's say, I don't know, 80 by 80. And if I zoom in, let's put the light edges on, edge displays on. Now this is basically obviously an approximation, but I think it's pretty good approximation. And now we're going to fix it here. And then I can do another one on the other side. And let's move it now. And about there, fix that. Okay, so basically I'm fixing it on a portion of the frame using these spot features, and on the other side you can see it's creating a constraint only on that portion of the geometry. Now if I go on the other side here, because this gangway is between 2 platforms, we're going to put like a slider constraint on the whole bottom of that frame there. And I think we are now, and we need to just create some loads. Now what I'll do here is just for the process, I'm just going to create gravity load in here. And in the Y direction this is set up, and hopefully now we are ready to run. I've based the analysis on the stiffness. Just want to give you an idea that how quick it was to create the welds or welded contacts, the right phrase. And now it's going to go through the 3 passes. And obviously something like this we would have to go through suppressing contacts in something like Inventor or Nastran. I think we're almost done. Okay. Okay, let's have a look at the displacement results. And let's just have a look at the animation. And have it a bit deformed. And I just want to show you at the sliding end. And you can see it sliding. Okay, I hope it's given you a quick overview. So let's get back to our presentation. Okay, so obviously I still get questions asked where to download the trial from. It's on our website. There's the link if you want to take a note of that. Just remember to click on the third-party products, because our website is actually pointed to the Autodesk Solutions, and you'll get a recording list of this webinar, and there's obviously support for the remaining of the COVID-19. I don't know how long the lockdown is going to be. It's not looking good. I think it's going all the way till September, October. Maybe some people are saying all the way till December. So we are offering full support to help you to trial out this software. And this is the most important, guys. Unless you already received emails from my marketing colleague, we are changing the way we are going to use webinars. We're using a platform called On24, so you'll be getting a new email from my colleague to re-register for the new platform. If you've done that already, thanks for that. I mean, the next two topics are pretty important. Bolted connections are very, very frequent question asked. Can we use Inventor connection fasteners? Why do we have to use, why can't we use them? So I'm going to go through that process. And then I've got a very large fabrication which is bolted and welded. So I want to go through that. It's an architectural example, so it is pretty large. Something like that is pretty impossible to do with Inventor and Nastran. So I hope you can join me for the forthcoming sessions. Next week is a break, after next week. And now I'll hang around for any questions you may have for the next couple of minutes. But by all means, you can send me an email for any questions. Okay, I'll be around, guys, if you need to send me a personal email. Okay, now I've got a question here for 3D connection space support for SimSolid. I am not sure whether SimSolid will support 3D connection. I can ask and get back to you on that. I know 2021 software is coming out pretty soon, so hopefully I could try that out with my Space Mouse. Okay, guys, thank you very much for your time, and hopefully meet you guys, at least virtually, in our forthcoming sessions. Thank you very much again, guys. Bye for now.